Hey everybody, this is Larry. This is day 10 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's forum. So the drone video is still in Armenia, but I am here in Tashkent in Uzbekistan, just chilling. So let me know what you think about the video, about traveling and all this stuff, and join the Discord, of course, you want to chat with me. But yeah, okay. And also, if you want to just like follow my journey, check out the Instagram, the gram. But okay, let's look at today's problem 1802, maximum value at a given index in a bounded array. Okay, what does that even mean? Okay, so you have three things, n index and max sum. You want to construct a nums array such that, okay, the n number, so it's a construction problem, or what do they call it? Constructive problem. Nums of I is positive. Adjacent numbers are different only by one. The sum of all the elements of nums do not exceed max sum. Nums of index is maximized. Okay. So basically, nums of index is maximized. Okay. And then I mean, my first inclination is binary search on the answer, because basically, I'm trying to, yeah, but basically you have this thing where you want nums of index to be the peak of a mountain, if you will, right? I mean, maybe it's a plateau, like a little bit flatter, but basically you want the, and I think that's the only thing that matters. Then yeah, then we should be able to binary search, because basically here, and I'll maybe use some ASCII, or maybe I would draw it if I had the chance. But basically, you have some mountain, right? I don't know how to visualize this. I don't have my usual drawing utensils, but basically you have this mountain, right? So all right, let me actually. I don't think I could do ASCII on this one very well. Let me try to draw with the touchpad. Hang on, let me set it up at least. I very rarely do this because usually at home in New York I have a drawing thing. But basically you can visualize this as like a mountain, like let's say, and it doesn't have to be a even mountain per se, but let's say you're and I'm gonna make it asymmetric so it does not appear in the middle. But basically you have this mountain, right? And every slope is -1 on both sides. And of course, if you have just more numbers, and this is the max it can be, because if you have more like if the max sum, let's say you have some left over from max sum, you can just kind of fill it out here, right? Like so that it goes up to max sum. But no matter what, it doesn't. It finds out or something like this, or maybe another way you could find it out is just add one here and then add one to the next one, add one to the next one, dot dot dot, and then just like and then facts, right? Whatever it is, it doesn't affect the peak right here, right? Because in order for this to go up by 1 unit, it means that you have all the things to do all the unit here and here, right? And that's I mean, it's possible. It's just that if you do the math and it's not, if you're a little bit short, then you can't do it. Okay, so that's basically the principle behind this one, I think. And when you do a binary search, then you're able to kind of do the answer on that one, right? Yeah, because basically on let's say we're testing a number x, right? Is the peak. Then on the left side you have you just do the math, and then they're like y numbers. So then you have 1 plus 2 plus 3 plus dot 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 plus x, right? And then on the right side as well, or maybe another way you can. Maybe that's not quite right, actually. Maybe the way to write it is x plus x minus 1 plus x minus 2 plus dot 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 all the way to n. Depending on so it doesn't go all the way to 1. It goes to like x minus n minus index or something like this, right? something like this. Maybe it's like off by 1, but you get the idea, right? It's just, you know, you keep on going down until you run out of numbers. And on the right side as well. Well, actually, this is an n minus index. This is just index maybe. But also like plus or minus 1. You know. Yeah. And the same thing on the right side. It's that, and then on the right side is what I was going to say, which is the n minus index. Again, maybe plus 1 or minus 1. And of course, if you just sum these two, x is doubly counted, so you have to subtract out x. But like I said, it is way, you know. So we could even write this formula, right? So we can go, I'm going to write calculate because I'm naming things as hard, but let's just call it the peak, and then just like the number of numbers, right? So count maybe. So of course this is just, you know, you could rewrite this as 1 plus 2 plus 3 plus dot 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 plus plus peak, and then you write the other one as well, plus dot 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 plus count, and of course you write the top, you got and then you subtract them out, right? So that's how. So then you have. No, I did this wrong, but it is essentially the same. It is the same idea. Sorry, it's way early in the morning. I need more sleep. But basically, it goes to peak minus count. The idea is the same, but I'm doing a terrible job explaining it. Right? Oops. Right, so you have these two things, and then after that, and the formula you can because you want to count from the peak, not count from the beginning. That's why I kind of messed up. But yeah, and then you gotta subtract these two to get count of the, so that this portion will have, you know, the count, right? And that's kind of what we have here, even though we use different terminology. So, and this formula, of course, is just what was it? Peak times peak plus 1 over 2 or something like this. Is it? It's either plus 1 or minus 1. I always mess that up. Let's say peak is 3, then the sum is 6, right? So then yeah, it's plus 1. Okay, right? And then you subtract that from. Okay, I just say top or is equal to this. Left is all a keyword probably. Total is equal to this. Left, let's just say edge is equal to peak minus count, and then we have edge times edge plus 1 over 2. This maybe this is minus 1. I don't know as well. And then we have total minus left, right? And then we well, we don't return it, but that's basically one of the things, right? This is longer than I expected, to be honest. Okay, so yeah, so that's how you calculate it, maybe give or take, you know, maybe we're off by 1 because I'm I don't know. Yeah, right. And next, what's next? Yeah, and then we do a binary search on the left and the right, and we should be good. So here, left is the 0, right is equal to, and this is just the regular binary search stuff. I'm looking at the thing, 10 to the 9, because so let's just say 10 to the 10 for a little bit safety. Yeah, and I do the inclusive bound so that when they equal each other, we're good. So mid is equal to left plus right over 2. Okay, if I always just write it good, right? If mid is good, what does that mean? That means that this number satisfies all the conditions. It may not be the maximum number, but it satisfies. So then that means that we want to try a bigger number where this number is possible, right? Where if this is not good, then we have to try a smaller number, and yeah, then we'll add 1 because of the minus 1. And yeah, and then we return left at the very end. We didn't calculate this, or we didn't define this function yet. So good of an x. So what is an x, right? Like we said, it's going to be calc of the. So this is the peak. So we want to say the left side. So let's say left sum is equal to the calculate of this, and then count is just. Is it? It's just index, right? So because if index is 2, then the 2 numbers to the left. And then we also do the thing to the right where, okay, if the index is 2, then there's only 1 numbers to the right, so it's going to n minus index minus 1. And note the abstractions of that, because I know that I hand wavy a lot of stuff around +1 -1, and it's because that I can, because you know we have abstraction, then we can change it easily without a lot of copy pasting. Now, like I said, I don't. Whoops, something is really wrong. If this is good, we try a bigger number, right? Okay. Oh, this is just returning. This isn't even. So we have to return this is less than or equal to max sum. Okay. To be honest, is this good yet? I'm still not confident. Confidence is a tough thing. You have to figure out what it means to you and experience, right? And here, for me, to be honest, this part is the part that I feel is the most risky. So I'm going to still test it, even though, you know, and this is probably, yeah. Yeah, so and it doesn't really take that much to test, to be honest, but basically just like, you know, maybe things that it depends on how you want to, or what kind of things you want to test. For me, for this one, it's about testing correctness, so I wanted to make sure that I just wanted to see things that I can test by hand and how it looks like, right? So 0, 0 is kind of silly. Okay, fine. So that means that 1 with 0 numbers to the left is 1 with 1 numbers to the left. Let's see, 1, so it's 1, yeah, okay. 2, 2, 2. Here's 2 and 1, okay. So it looks okay. So I think we're good here. Yeah, 7 plus 6 plus 5 plus 4. Okay, yeah, so I feel like we're good. So let's give it a minute. Hopefully I didn't miss any edge cases. Oh, and I did miss an edge case, as I said. Not really an edge case. This seems pretty basic. How did I miss this? All right, so what is wrong with here? Like I said, it's very easy to do an off by 1, but that's why I'm not confident about it. And apparently rightly so. Okay, so 3 numbers, index is 2. So the last, next number is 18. Okay, let's. Oh, why did I write -1? It's minus x. We said x, but then I don't know why. Oh, now it's all wrong. But at least we're consistent. Oh, I looked at the wrong thing anyway. But yeah, as we said, this was double counting. Yeah, that was a really weird mistake, to be honest, because I don't know where. Maybe I was just talking about off by 1 and I confused myself. But okay, let's take a look. Our answer is 3. 3, the last sum is 5. What is the maximum for this one again? 6. 3, 5, and then okay, so the number is 3. What is the parameters here? 4. So if I try 3, it should be 1, 2, 3, 2, right? So that's the peak. And what is the sum here? The sum here should be 6, 8, right? So this is 8. What we have is left. So right is maybe off by 1 somewhere. No, the right is, well, the left and the right is definitely wrong, because for 3, this should be 5, right? Where here it should be 6 even. So this is 2. Oh, I did the index for the number of things, but I didn't count itself, so this should be +1. I think I did the index not counting itself. So then I did the math wrong. Okay, yeah. Okay, so that looks good. I don't know how you, sometimes you get lucky with the wrong answers. And apparently I'm still wrong, which is fine, but that's a little bit sad, but fine. Okay. Okay, what is this? So 7 numbers on the left, 2 numbers on the right. So we try 5. Oh, I see. It's a little bit awkward, isn't it? Man, I'm making a lot of silly mistakes today. It's a little bit awkward because we have negative numbers. I think that's the reason. Because basically for 5 and we have 7 numbers, we could have, oh no, it's a, oh, okay. So actually I made a mistake here. I thought you could have negative numbers, which is why, yeah, if we could have negative numbers, this would work. Maybe, I don't know. Because let's see. So basically, if we have 5, then we have to do 1, 2, 3, 4, 5. This is 7 numbers, I think. Yep. And then 4 on the right. So this should, the right side is also off. This should be 9. Did I mess up? No, maybe I just. Okay, at least I don't know. I thought we checked this, but apparently not. But anyway, so then the left is 12. So then let's do this, right? Okay, so at least we fixed this case. Basically, it's still not fixed though, is it? I mean, we fixed the 9, so I guess that makes sense, and that is fixed. But left sum should be 9, 12, 14, 15. It's not doing this thing, so that's not great. Huh. And x and index plus 1, so am I doing this wrong? Okay, there you go. Now the sum is correct. I thought this should fix it, but maybe the 2 negatives made it confusing. Okay, fine. I am bad at math. This is how you actually fixed it. I fixed it incorrectly. Okay, so I mean the idea is still correct. I actually missed the part about its positiveness, so we just have to handle it a little bit differently. I thought you could do negative numbers for some reason. I don't know why. A lot of silly mistakes. Okay, so then now we can go back to seeing why this is wrong. Maybe it's just an off by 1. But okay, so the 3 numbers, the last number is whatever. So then am I just like bad at indexing? I don't know, because this should return 0. Oh, why is this not returning 0? So for 3 we have 2, so we have 3 numbers on the left. 3 numbers is 5, 4, 3. That's 12. That's correct. But then on the right, I don't know how we get 9. So 3 minus 2 is 1. Is this plus 1, right? Okay, now it's right. I don't know why this was... Oh, okay. I think I misread this one on the 7th index. For index is equal to 7, it's actually the 8th number. And then it just kind of cancels each other out. Okay, fine. Hopefully this is right now. And yeah, this. Oh, index 0. I messed up index 0. Wow, I am like struggling here. I think last time I did it in the first try. We'll see how that goes, but I don't remember struggling on this one at all. I think I'm just kind of having a tough day, I suppose. But let's give it a spin. Okay, so index is at 0, right? Let's bring these back again so I can debug it. At least we're having a good time debugging. That part isn't that bad. So for 2, left side is 2, right side is 2 and 1. For 3, that's 5. And what's the maximum? Maximum is 4, so 2 is not good, right? Wait, what? Why does it think it's good? 2 on the left, 1. Because we double count on the 2. Right. So index is 2, 1 dot dot. Why is that not a right answer? Am I missing something still? You think the answer is 1? Did I miss something? Am I misunderstanding this problem now? Actually, I think this should be right? Is this not? It thinks that the expected answer is 1, but 2 is okay. Is it not? Because this is the case. A positive integer. Oh my god. I see. Because for some reason I read that as non-negative, because as you can see from all my zeros. So we've been solving like 3 different problems today. So that's kind of interesting. I don't know. I mean, you could look at it as getting a lot of wrong answers, but and maybe one of them I just had a typo, to be honest. But in solving different problems, kind of, to be honest. So yeah. So okay. So then now we have to convert these to 1s. So then that's not that hard per se. But we just have to kind of change this formula again. So that's the good part about abstraction, is that once you do that, then you can figure it out, right? Basically, I was assuming that we could pad the rest with 0s, but now we have to pad the rest with 1s. So I have to think about, I mean, it's not that hard. We just have to kind of do it this way, right? If peak is less than count, then left over is equal to count minus peak, and they all have to be 1s. So yeah, so it's just this minus leftover is the the sum. No, it's this plus leftover, and then the other part will get rid of it. Yeah, okay, see, I mean, it's a very easy fix, but I think I just well, one is clearly I misread it or misinterpreted it. I think we read it together. But good part about that, maybe, hopefully, if you're watching it all the way to here, is that you can see where, 1, you see how I debug, and 2, you can see where how to fix it, right? Like, these fixes are pretty easy. You know, I went from all numbers to non-negative, including 0, and then I just did it for or only positive, right? And you could kind of see how I did the math and kind of progress. So hopefully that makes sense. Apparently, what did I do? Oh yeah, I did do binary search the other time, but Oh, and then I just did the extra. So I guess I was very careful last time, but or at least I read the prompt correctly. Because as soon as I read the prompt correctly, I think this was fine. But I clearly struggle along with that. So yeah, that's all I have for this one. Let me know what you think. Sorry, I'm having some like allergy issue right now, but yeah, but this is binary search. It's all of or where or is or log or where or is the range of the numbers. This is linear. Oh no, sorry, this is constant and this is constant. So everything is constant except for the binary search. So yeah, that's all I have for this one. Let me know what you think. Hope the struggle makes sense and you can see how I fix everything. But yeah, stay good, stay healthy, to good mental health. I'll see you later. Take care. Bye bye.